Hello everyone, in this video I'm going to discuss the example for limits and continuity. Kindly refers to A. Evaluate the limit when x approaching negative infinity for the function 3x plus 2 over square root 4x squared minus 3. So first of all, if we substitute the infinity, and we will have the situation negative infinity over the positive infinity, where we have the indeterminate form. So the suggested strategy would be dividing the numerator and the denominator by the highest power of x for the denominator. So in this case, our highest denominator will be square root of x squared. So meaning that is x. So first what we have to do is to factor out the x for the numerator. So limit when x approaching negative infinity. We factor out the x and we have 3 plus with 2 over x. Over, we have the square root. Factor out the x squared. So we have 4 minus 3 over x squared. Kindly simplify the situation. So limit when x approaching negative infinity, where we have x bracket 3 plus with 2 over x over, we have the square root of x squared, square root of 4 minus 3 over x squared. So notice that we have square root of x squared. Square root of x squared actually equals to modulus of x, where we have the definition, we have the x with the domain x greater equals to 0, we have the negative x with the domain x less than 0. By referring to the number line, we have the 0. For the left hand side, we have negative x. For the right hand side, we have the x. So based on the situation in here, we have the negative infinity. So we have to make use of the negative x. Limit when x approaching negative infinity, we have the x multiplied with 3 plus with 2 over x over, in this case, we have negative x. Multiply with the square root of 4 minus 3 over x squared. So can I simplify? Limit when x approaching negative infinity, we have 3 plus with 2 over x over, we have the square root 4 minus 3 over x squared. So do remember, here we have the negative. So if we substitute the situation, and we will have 3 over negative 2. So limit when x approaching negative infinity, for the situation 3x plus with the 2 over the square root of 4x squared minus 3. The value of y will be approaching negative 3 over 2. So where we have this one as a horizontal asymptote. Kindly refers to B. Given we have the function fx with the focus x is equals to 5. Find the value a and b such that the function is continuous for all value of x. So my suggestion will be illustrate the situation in a real number line. So here we have the value 5. For the left hand side, we have x less than 5. So meaning that here we have x squared plus with the bx minus 2a. When x is equal to 5, we have the function a. For the x greater than 5, we have ax plus with the 3. So for this case, in order to find the value a and b, we have to make use of the conditions of continuity. Number 1, we have f bracket 5, and the value of y is equals to 8. Second condition, limit when x approaching 5 for the left, the function is fx, which is equals to limit when x approaching 5 from the right for the function fx. So kindly substitute the situation. So limit when x approaching 5 from the left for the function, we have the x squared plus with the bx minus 2a equals to limit when x approaching 5 from the right for the function, we have ax plus with the 3. So kindly substitute the value. So in this case, we have 25 plus with the 5b minus with the 2a equals to, we have 5a plus with the 3. So kindly rearrange the situation. So here we have the 22 equals to, we have 7a minus with the 5b. So that is the first equation. Condition number 3. f5 is equals to the situation. We have the limit when x approaching 5 for the function fx. So notice that for this case, my suggestion would be picking the right hand side. So here we have the value 8. Limit when x approaching 5 from the right for the function ax plus with the 3. So 8 is equals to, we have 5a plus with the 3. Continue, 5 is equals to 5a. So a is equals to 1. So kindly substitute the situation. A equals to 1 into the first equation. 22 is equals to 7a minus with the 5b. So rearrange the situation. We have 5b is equals to 7 minus 22. So 5b is equals to negative 15. So b is equals to negative 3. So we have the c. Given we have the y is equals to x plus 1 over x minus 4, x plus 2. By finding the limits at appropriate point, obtain the horizontal and the vertical asymptote. So here we have another function, y is equals to x plus 1 over, we have x squared minus 2x minus 8. So that is the expansion form. So for the left hand side, we have the simplest form, and then for the right, we have expansion. So number 1 is to find the domain. By referring to the situation, we have the domain negative infinity until negative 2, union negative 2 until 4, union from the 4 until infinity, where the negative 2 and 4 is not included. Next, focus on the limit when x approaching negative 2 from the left. Limit when x approaching negative 2 from the right. Continue. Limit when x approaching 4 from the left. Limit when x approaching 4 from the right. So kindly substitute the function. So x plus 1 over x minus 4 multiply x plus 2. So here we are going to find the vertical asymptote. So number 1, focus on this part, we have the negative 2 and also the 4. The value approaching the negative 2 from the left would be negative 2.0001. As for the right, then we have negative 1.9999. Then for the 4, we will have 3.999 and 9. And finally, we have 4.0001. So now we are going to substitute the situation. So making use of the negative 2.0001, substitute into this part, and we will have the situation negative. If we substitute in this part, we also have negative. Same goes to this part, we have the negative. So we have negative infinity. Meaning that limit when x approaching negative 2 from the left for the function fx, and the value of y will be decreasing without limit. Next, we're going to substitute this value. Here we will have the negative. If we substitute this part, we will have a negative. If we substitute this part, and we will have positive. So the value of y will be increasing without bound, as the x approaching negative 2 from the right for the function fx. Continue. Focus on this part. If we substitute, and we will have the positive value. If we substitute this part, we will have a negative value. If we substitute this part, and we will have positive value. So limit when x approaching 4 from the left for the function fx, the value of y will be approaching decreasing without bound. Next, focus on this part. If we substitute, and we will have positive. Then for this part, we will have positive. Same goes to this part, we will have positive. So as x approaching 4 from the right for the function fx, the value of y will be increasing without bound. So from here, we can say that the vertical asymptote are x is equals to negative 2, x is equals to 4. Next is to find horizontal asymptote. Limit when x approaching negative infinity. Limit when x approaching positive infinity. We need to substitute the expanded form, where we have x plus 1 over, we have x squared minus 2x minus 8. Next, if we substitute the situation, and we will have negative infinity over the positive infinity, where we have the indeterminate form. So the suggested strategy will be dividing the numerator and the denominator for the highest power of x for the denominator. So for this case, the highest powers for the denominator will be the x squared. So kindly factor out the x squared. So here we will have 1 over x plus 1 over x squared. Over, we have x squared, 1 minus 2 over x minus 8 over x squared. If we simplify, limit when x approaching negative infinity, bracket, we have 1 over x plus 1 over x squared. Over 1 minus 2 over x minus 8 over x squared. So if we substitute in this part, and we will have 0, 0, 0, and 0. So finally, we have 0 over 1. So limit when x approaching negative infinity, for the function, we have x plus 1 over x squared minus 2 minus 8. The value of y will be approaching 0. Same. On the right hand side, limit when x approaching positive infinity, we have the situation 1 over x plus 1 over x squared. over, we have 1 minus 2 over x minus 8 over x squared. If we substitute the infinity, and we will obtain 0 for the highlighted part. And finally, we have 0 over 1. Limit when x approaching positive infinity for the function x plus 1 over x squared minus 2x minus 8. The value of y will be approaching 0. So finally, the horizontal asymptote is y is equals to 0. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.